Good morning. Today we'll discuss about high definition television, the LCD TV and LED TV. At first, a bit of historical review. The high definition television was introduced in the market in the year 1998. What is the speciality of a high definition television? Well, as the name indicates, it offers superior resolution of visual content than the normal TV. The normal TV is our analog TV. We can classify TV systems broadly into three categories. One, analog TV, which uses analog signals as the message signals. Then a digital television where the message signal is digitized before transmission. And then three, high definition television or the HDTV, of which we are concerned now. In fact, the high definition television is a subset of digital television. High definition television comes under the purview of digital television itself. How does this analog TV work? The working of analog television, as the name indicates, it uses analog signals as the message signals. Analog signal is a continuously varying radio wave signal, which is sent using an antenna and received using another antenna. We can use air as the channel, or you can use cable as the channel, or you can directly take the signals from the satellite. Again, we say that the channel is air in the case of satellite communication. Now, analog TV uses 6 megahertz bandwidth. The digital signals are converted into analog before the transmission in the case of analog TV, because it cannot propagate digital signals in the analog system. Now, the display device is usually a CRT monitor, the cathode ray tube television, which was our old TV sets. What are the disadvantages of analog TV? The first disadvantage is that it has only 480 visible lines of pixels. A pixel is a picture element. The number of lines on a CRT monitor, a cathode ray tube monitor, is only 480. And the disadvantage is that if you make a big TV, then the separation between these lines of pixels will become more, and that will degrade the image. The image will not be that sharp as in a small TV, because in a small TV as well as in a big TV, the number of lines is 480. This limitation is the first disadvantage of a cathode ray tube TV or a normal analog TV. Then the second disadvantage is that analog pictures are interlaced. What is interlacing? Interlacing means, suppose we have, as we have discussed, we have 480 lines. Let this be the first line, and this the second line, this the third line, and this the fourth line. When a picture is shown, it is not shown fully in an analog television. Part of the pictures, the first line and the third line, are shown at first. After the first instant, after a small interval of time, the second line, the fourth line are shown. This is called interlacing of pictures. For the whole 480 lines, 240 odd lines are shown at first, and after that the second 240 even lines are shown. And this will make sometimes flickering of the image. That is the second disadvantage of analog TV. Then there is another disadvantage when you convert a video to analog format that will lower the quality of the signal. We have discussed that in the last slide that you want to convert digital signals from a DVD to an analog signal so that you can transmit it through an analog transmission device. And this will lower the quality of the visual content. Now, how does a digital TV work? A digital TV uses digital signals instead of analog signals. And these digital signals are usually zeros and ones, we know this, or quantized values of voltages and current. For air transmission, ultra high frequency is used in the case of digital television, and in the case of analog television also, ultra high frequency is used in the case of air transmission. And it uses the same bandwidth as the analog television, which means it uses 6 megahertz as in the case of analog television that you will see here. So analog television and digital television both use the same amount of bandwidth. Both take same amount of bandwidth for its working. Now, the other advantage of digital television is that the picture will not lose its quality even if it is displayed on a small TV or in a big TV or a bigger TV. Then it can support higher resolution than these 480 lines as in the case of analog television. So the picture will be good when it is shown on a larger TV or a larger screen. Then instead of interlaced scanning, the scanning can be progressive. This means the whole lines are shown all together. Unlike the case of analog TV where the odd lines are shown first, then the even lines are shown. In the case of a digital television, all lines are shown together, which means a picture is shown as such, or a screen is shown as such fully, not in parts. So a frame is shown at each instant instead of every other line of pixel or the interlaced scanning technique. So the flickering problem is avoided. Then another advantage is that with the same bandwidth, with the same 6 megahertz bandwidth, more than one channel can be transmitted by a single broadcast station. This is not that easy in the case of an analog signal. When you convert a signal into a digital signal, you can use many techniques like code division multiple access, time division multiple access, and many other more techniques so that you can transmit more than one channel using the same bandwidth which is allotted to a single broadcaster. If the broadcaster decides, they can include interactive information also with the digital television. Then it can support high definition television. High definition television means high resolution television broadcast can also be done with digital television. Now, what is the disadvantage of digital television? The only disadvantage is that the analog TV that we use, the big TV, the cathode ray tube TV cannot decode and display the digital signals. So what do? We need to convert the analog signals. When the analog signal, if the analog signal ends, only digital transmission is taking place. That's what we see now. The analog signals in India is being replaced with digital signals. When the analog signal broadcast comes to an end, we need to, if you want to use our old TV, we need to use a set-top box which converts this digital signal back to analog signal and supplied to the analog TV. And this will again deteriorate the quality of the picture. So this is the main disadvantage of uh, digital television. In fact, it is not the disadvantage of the digital television, but it is a disadvantage of the analog set that we have in our hand. Now, high definition television. Who decides the standard of high definition television? There is a committee called Advanced Television Standards Committee, or ATSC. This is an international organization, international committee, which specifies the digital standards for the visual content as well as the audio content, and what are the type of encoding that is used. All these things are decided by the ATSC. The high definition standards, HDV, HDTV standards are the top tier of all the digital standards, which means, as I said earlier, the digital television, the high definition television is a subset of digital television. The highest quality digital television is high definition television. We could say like that. Now, there are 18 formats which are adopted by ATS or which are accepted by ATSC. And they differ. These 18 formats differ in three aspects, three formats. The first one is the aspect ratio. A standard digital television has a 4:3 aspect ratio, which means the breadth of the screen will be 4 and the height of the screen will be 3. But in the case of high definition television, which is the top tier, which is the highest quality television, the aspect ratio becomes 16:9, which is aspect ratio, which is the aspect ratio of a movie screen that we see in theaters. This is the 16:9 screen that we usually see in an LED TV or in an LCD TV, which are supposed to support the high definition television. Now, the second thing on which the digital television differ is the resolution. The lowest standard resolution of the lowest standard resolution of a digital television is equal to the highest standard resolution of an analog TV. And the lowest resolution is 704 by 480 pixels. This is the highest standard that can provide by an analog TV. And the highest resolution, of course, will be that of high definition television, and the resolution is 1920 by 1080 pixels. This is the highest resolution that is possible in the case of high definition television, which means HDTV can display about 10 times as many pixels, meaning the visual content will have that much richness in the case of high definition television than in the case of an analog television. Now, the third aspect is the frame rate. A set's frame rate describes how many times it creates a complete picture on the screen every second. We know that we are seeing the motion of pictures due to the persistence of vision. A visual will remain in the brain or in your retina for 1/10 of a second. So if another frame comes within that time frame, you will see that you will see a continuous motion. For that purpose, normally 24 frames are shown in a second. This is the minimum number of screens, minimum number of frames that is needed for a continuous effect. That is represented by 24p. But there are TVs in high definition television, for example, the frame rate is much higher. The frame rate may rise up to 60p, which means 60 frames are shown per second. So this is the third aspect in which the digital television differs. So these are the three aspects in which the digital television differs. One is the aspect ratio of the screen. Then the second one is the resolution of the screen. And the third one is the frame rate. So we can summarize all these things, all these categories, these 18 categories into this chart. So these are the different type of digital televisions that are available. Up to 704 by 480 pixel, we call it standard digital television. And when the resolution increases to 1220 by 720, we start to call it high definition television. And the top tier of this resolution is 1920 by 1080 with an aspect ratio 16:9 and a frame rate 60i. This is the top tier of all digital television, which is called the high definition television. Now about the encoding in digital television. How pictures as well as sound are encoded in a digital television. They use a technique called MPEG2 or MPEG2. In this encoding system, the content is compressed to a factor of 55:1, which means a camera takes a lot of visual content which is not perceived by human eye, and all those visual information which a human eye cannot perceive are removed using MPEG2, and you know that 55 out of 56 information cannot be perceived by human eye, which is seen by the camera. So it is compressed by a factor 55:1, and this helps in reducing the data. With minimum data, you can watch more content. Now we have two types of high definition TV systems. The first system is called LCD, the liquid crystal display, and the second system is called LED, the light emitting diode display. LED. Now, what is the difference between LED TV and LCD TV? Basically, there is only one difference. Both these systems use liquid crystals. Liquid crystal has to be illuminated on its backside. This illumination is done in the case of LCD TV by a standard fluorescent tube or a compact fluorescent tube. But in the case of an LED TV, this illumination on the backside of a liquid crystal is done by an LED. This is the basic difference and the only difference between LCD systems and LED systems TV. What are liquid crystals? Liquid crystals are actually rod-shaped polymers that naturally form into thin ordered layers. You can see the liquid crystals forming ordered layers in the picture. These are the ordered layers. These are liquid crystals. Now, there is a special type of liquid crystal called nematic phase liquid crystal. What is a nematic phase liquid crystal? A nematic phase liquid crystal is a type of crystal whose twisting can be adjusted by giving current or giving a voltage. For a given voltage or for a given current, the twisting will be untwisted for a given angle. This can be predicted. So the amount of untwist and the amount of voltage are related by a factor. And you can predict the amount of untwisting for a given amount of voltage. Such type of crystals are called nematic phase liquid crystals. And these nematic phase liquid crystals are used to make LCD TV and LED TV. We will talk about the details of these nematic crystals and the formation of or the construction of LCD and LED TV in the next class. But before leaving, let's see how these work, the nematic crystals work. You can see these blue ovals are the nematic phase crystals. They are naturally twisted. The twisting is shown here. When you give a light with a vibration in a vertical plane, and if the first nematic crystal is aligned in the vertical direction, that will receive, the nematic crystal will receive the light without any fail. And when the light comes to the next crystal, as the crystal is turned a little, the plane of vibration of light will also be tilted by that much angle. And in the next crystal also, which is also tilted by a, a bit of angle, a small angle, again the light is twisted by that much angle. When the light reaches, when the light reaches the last crystal, the light will be vibrating, or the vibration of the electric field of light will be parallel to the last crystal. If that last crystal is perpendicular to the first crystal, then that means the vibration of light is made perpendicular to its initial direction. So the light entering with its vibration vertical to the first crystal, with its vibration in the vertical plane in the first crystal, will leave the last crystal with its vibration perpendicular to the first crystal or perpendicular to the initial vibration. Suppose when you give, if you are giving a voltage, then these nematic crystals twisting is untwisted. The twisting is distorted. So what happens? The light cannot pass through the nematic crystals because the vibration of the light is not parallel to the orientation of the crystal. So no light will come out of the last crystal. So using this technique, you can create darkness and you can create brightness. This is how a nematic crystal work. Using these nematic crystals, you can make LCD or LED TV. And how do we make use of this particular phenomenon, and how do we make these LED and LCD TV? We will discuss in the next class.